Partial variation involves a situation whereby a quantity is related to the sum of two variables or to the sum of a constant and a variable. We have some examples that exhibit partial variation. The first one is equations of straight lines, and the other one is the cost of running a business. Now, if you remember, the cost of the equation of a straight line is normally of the form y is equal to mx plus c, where m is the gradient, x is the variable x, and then c is the y-intercept, which is always a constant. And then when you consider the cost of running a business, you realize that there is that cost, which is normally fixed regardless of the volume of activities that you undertake in a business. And there's that part of the cost that varies depending on the volume of activities that you undertake in the business. So we have an example here. The quantity y is partly constant and partly varies as x. Given that x is equal to 4 when y is 14 and x is 8 when y is 22, we have to find the equation connecting y and x. Hence, we find the value of y when x is 20. So in this case, in this question, we realize we can see a word partly and partly here. So those are the indications that the question is on partial variation. So how we come up with what we do is that we first of all come up with a mathematical relationship between the two variables. So a quantity y is partly constant and partly varies as x. Mathematically, we write y is equal to c plus kx. C stands for the constant we are talking about here. And then we are told it also, this y varies also as x. So we have x here. But because this x could be having a constant here or a coefficient, then we introduce the constant of proportionality, k. So k is a constant of proportionality, which stands for a coefficient of x which may be existing. Now, having written it in this format, you notice that in this format, we don't necessarily have to use the variation sign as we did in the previous two lessons. We just go direct to an equal sign. Now, given that x is 4 when y is 14, this statement here, if we pick this statement and we substitute it in this equation, we shall say when x is 4 and y is equal to 14, y, instead of y, we shall have 14 will be equal to this c plus, instead of x, we write 4, so we shall have plus k times 4. If we simplify that, we shall have 14 being equal to c plus 4k. And that gives us the first simultaneous equation. Then we pick the second part of this statement up to here. Sorry, from here. X is 8 when y is 22. So we shall say when x is 8 and y is equal to 22, let us substitute them in this incomplete equation. We shall have 22 being equal to c plus k times 8. This simplifies to 22 being equal to c plus 8k, and that is another simultaneous equation. Now, we pick the two simultaneous equations and we solve them. So there we have them. This is the first simultaneous equation, it's here. This is the second one. We don't have to do any adjustments in these equations when we are using elimination, because we realize the coefficient here is 1 and the coefficient here is 1. And if the coefficients have similar signs, we need to subtract the two equations. But if they have different signs, meaning one has a positive sign and another one a negative sign, then we add the simultaneous equations. Now this one has positive 1 and this positive 1, and therefore we shall just have to subtract them. 14 minus 22 gives us negative 8, being equal to c minus c is 0. Then 4k minus 8k gives us minus 4k, like that. We need k, so we need to divide both sides by the coefficient of k, which is negative 4 in this case. If we do that, divide by negative 4 on both sides, you realize that this cancels once like that. Then this 4 Negative 4 cancels here once, and it cancels up here twice. So our k is equal to 2. So we have found the value of k, but we have not found the value of c. For us to get the value of c, take either the first simultaneous equation or the second one. Where you see k, substitute it with the 2, it will help you get c. So we take the first simultaneous equation. We shall have 14 is equal to c plus 4 into 2, because we have found the value of k to be equal to 2. When you do that, you will have 14 being equal to c plus 8. Take this c across equal sign. We shall have 14 minus 8 being equal to c. In other words, our c is equal to 6. So we have found the value of c to be 6 and that of k to be 2. We can substitute them in this incomplete equation and it will be complete. So we shall write, therefore the equation connecting y and x is equal to y is equal to c is 6 plus 2x plus 2x, like that. So that is the law or the equation connecting y and x. The question says, hence find the value of y when x is 20. So we shall now take this portion of the statement and say, when x is equal to 20, what will be the value of y? Y will be equal to 6 plus 2 into, instead of x we write the 20 here. And if you do so, you will get that being equal to 6 plus 40, and that is 46. So that means when x is 20, the value of y will be equal to 46. Then the next question, we have another example here. A quantity p varies partly as the square of q and partly as q. Given that p is 65 when q is 5 and that p is 230 when q is 10, determine the equation connecting p and q. So to achieve that, we shall come up with the mathematical representation of this first statement. We shall say, we are told p varies partly as the square of q. So we shall have p being equal to aq squared. Why aq squared? It's because we are told p varies partly as the square of q. Square of q means q squared, but we introduce a, which is a constant of proportionality, and it stands for a coefficient of q squared, which might be in existence. So a, we write this a to stand for any constant that could be the coefficient of q squared. And then we are told it also varies partly as q, so we shall write plus q. But again, because this is a variable, we also have to assign it, we have to assign to it another constant of proportionality, which we have decided to call b. So this is just a constant or a coefficient, and this is also another coefficient. These values could be the same or they could be different. Now, having written this general form, this is the general form of this equation statement here. We take this part of the statement, this first part here, and say when p is 65 and q is equal to 5, then p will be equal, we shall have, instead of us having p, we shall have 65 being equal to a times q squared. Our q is 5, so we shall have a times 5 squared plus b times q, which is 5, so b times 5. Simplify that, you will get 65 being equal to 5 squared is 25 times a gives us 25a plus b times 5 gives us 5b. That gives us a simultaneous equation. Then we come to this second part. P is 230 when q is 10. We also substitute it in this equation to help us get another simultaneous equation. So we shall say when p is 230 and q is 10, instead of p we shall have 230 being equal to a times q. Q is 10, so it will be a times 10 squared plus b times 10. Simplifying that, we shall have 230 being equal to 100a, because 10 squared is 100 times a gives us 100a, plus 10 times b gives us 10b. This is another smoothness equation. Now, having achieved getting these two smoothness equations, we can pick them and solve them. So we have them there. Of course, there are so many ways of solving smoothness equations. I've decided to use elimination, and I've realized that if I take 2 and multiply by it here, we shall have the coefficient turn to 10, and they will be similar. So I will have to multiply the whole of this smoothness equation by 2 as I retain this one. So we shall have it look like 2 times 65 gives us 130, being equal to 25a times 2 gives us 50a, plus 5b times 2 gives us 10b. For the lower one, we are not tampering with it, we just pick it the way it is. You notice that now b has equal coefficients. If these equal coefficients have similar signs like they do, we subtract the two smoothness equations. So we shall subtract there. 130 minus 230 gives us negative 100, being equal to 50a minus 100a gives us negative 50a. And then this one, of course, is 0. So we want a, therefore we divide both sides by negative 50. And you realize that this negative 50 and this negative 50 will cancel. Then negative 50 cancels here twice. So we shall have a being equal to 2. Behold, we have found the value of a, but we have not found the value of b. So you can take any of these smoothness equations, either the first one or the second one. We substitute a with the 2, it will help us get b. So if we take the first smoothness equation, we shall have 65 is equal to 25a plus 5b. This is the first smoothness equation. Replace a with 2, we shall have 65 being equal to 25 times 2, because we have found the value of a to be 2. Then plus 25, meaning 65 is equal to 50 plus 5b. Take 50 across equal signs, we shall have 65 minus 50 being equal to 5b. We want b, so we can first of all simplify this. This one gives us 15 being equal to 5b, and then divide both sides by 5 because we want to remain with b. When you do that, of course, 5 and 5 cancels. 5 cancels here 3, so our b is equal to 3. That means our a is 2 and b is 3. In that case, then we can come back to our incomplete equation, this one here, and we write it in full form, where we shall replace a with the answer and b with the answer. So the equation now will be p is equal to 2q squared plus 3q. That is the law connecting p and q. And that is what the question wanted. So up to that, I think we shall stop there. We have an assignment for us today, so you can try this question, and then I will share the answer later in the course of the day tomorrow. Thank you.